Picture this. You're on a silent, freezing glacier in Iceland. It feels like the coldest, most desolate place on Earth. But just a few miles directly beneath your boots, an ocean of liquid fire is churning. A restless magma chamber radiating violent, prehistoric energy. For all of history, our instinct was to run from that fire. But what if we didn't? What if we drilled straight into it? We are talking about piercing the heart of an active volcano. Imagine a pitch-black shaft dropping miles into the earth, leading directly to an inferno where temperatures can liquefy solid steel in seconds. It's a multi-billion-dollar gamble with the laws of physics. One tiny miscalculation could trigger a catastrophic man-made eruption. Calm. Welcome to Engineering the Impossible. Today, we're deconstructing a megaproject that sounds like science fiction, the Magma Tap.
Just 1% of the Earth's internal heat could power all of humanity for 2 million years. We're tapping into a gold mine.
Let's face it, our power grids are gasping for air. Between explosive AI expansion and the birth of next-gen megacities, we desperately need a limitless, perfectly clean baseload power source that never stops. To find it, our mission takes us to Iceland. Up top, Arctic winds scream, but deep underground, a fiery monster is waiting. Engineers have drafted a mind-bending $50 billion master plan to tap directly into a magma chamber.
Iceland sits directly atop a mantle plume. It's one of the few places on Earth where the magma is actually reachable.
Quick reality check. While this specific facility is a conceptual design, the machinery, the terrifying thermal physics, and the extreme construction are 100% real. Right now, this tech is being tested on the most dangerous geothermal megaprojects on Earth.
So how do you reach the magma? You have to carve a flawless artery through miles of incredibly dense volcanic rock. A standard oil drill? Not even close. You need a titan. Engineers deploy a vertical tunnel boring machine. Think of it as a subterranean robotic cruise ship built solely to grind solid granite into fine dust. Its business end is a massive iron shield fitted with dozens of spinning tungsten carbide cutters.
Tungsten carbide is nearly as hard as diamond. It's the only material tough enough to chew through miles of solid volcanic crust.
As it bites deeper, it hauls mountains of debris back to the surface. But then, the environment violently fights back. Near the magma, ambient temperatures spike over 1,000 degrees Fahrenheit. Standard drill bits would melt like wax left in the sun. To even survive, this machine is clad in advanced space-age heat shields, the exact same technology protecting spacecraft during atmospheric re-entry. Meanwhile, a relentless cooling loop pumps millions of gallons of icy water straight down the shaft to keep the drill's tungsten teeth from boiling into useless slag. Okay, you've carved the hole. Job done, right? Wrong. The moment that shaft opens, the mountain tries to close it. The geological weight pressing in acts like a planetary vice grip. Left unsupported, the tunnel would instantly collapse. To stop this, the shaft gets lined with unyielding steel and ultra-high-density concrete. But here is the nightmare. How do you pour wet concrete when the extreme heat would instantly flash boil the water into explosive steam?
Concrete generates its own heat while curing. In a volcano, that's a recipe for an explosion. The ice pipe trick is a total game changer.
The solution is a frankly brilliant feat of thermal management. Engineers embed a network of steel piping into the concrete lining. By pumping pressurized ice water through them, they act like a massive refrigerator, literally sucking the heat out of the curing concrete. It sets perfectly inside a subterranean inferno.
At these depths, the drill bits are essentially breathing ice water. Without this constant flow, the metal would liquefy in minutes.
The craziest part? The pour must be perfectly continuous. Even a single pause creates a microscopic flaw, a cold joint that could lead to a catastrophic total collapse. Now we reach the most dangerous phase, the approach. Let's be clear, we do not drill directly into liquid magma. That's a guaranteed recipe for disaster. Instead, the drill stops mere feet short of the ultimate barrier. To manage the immense risk, the concrete structure is woven with thousands of delicate fiber optic sensors. Every microseismic tilt is reported in real time to a heavily armored surface control room.
Thousands of fiber optic sensors act like a nervous system for the shaft, feeling every tremor before it becomes a disaster.
So, what's the goal? A closed-loop geothermal heat exchanger. We pump highly pressurized pure water down a central steel pipe. As it approaches the magma zone, the heat transfer is so intensely violent that the water skips the boiling phase entirely. It becomes supercritical, a bizarre, alien state of matter. It's denser than steam, flowing like a gas, and capable of carrying an unimaginably massive amount of thermal energy.
Supercritical fluid is a physics freak. It has the density of a liquid, but moves with the speed of a gas. It's the ultimate energy carrier.
Back on the freezing surface, all that violent energy is harvested in a powerhouse built like a military fortress. Because Iceland is an active seismic hotspot, the building doesn't sit rigidly on the bedrock. It literally floats on top of massive seismic dampers. They act as giant shock absorbers, allowing the facility to safely sway during earthquakes as the ground shatters beneath it.
These dampers act like 50-ton shock absorbers. When the earth shakes, the building stays still. It's literally floating on engineering.
Inside, the supercritical fluid rockets up from the deep and slams into the blades of gargantuan Francis turbines. These 600-ton masterpieces spin at terrifying speeds. If they were misaligned by even a fraction of a millimeter, the sheer kinetic force would vaporize the turbine hull. As these massive turbines rotate, they drive heavy generators, converting the chaotic violence of the volcano into millions of watts of clean, reliable electricity. The steam is condensed back into water and sent right back down the shaft. A flawless, self-sustaining loop, zero emissions, endless power.
Because it's a closed loop, we don't waste a single drop. It's the closest thing to a perpetual motion machine we've ever built.
They told us drilling into an active volcano was a suicide mission. They said the mind-boggling heat and crushing pressure were insurmountable. But history is built by those willing to push the absolute limits of human ingenuity. Today, we didn't just look at a hole in the ground. We looked at how humanity can reach down, tap into the beating, fiery heart of our planet, and harness it to power the future of civilization.
If we can master the Magma Tap here, we could potentially unlock clean, limitless power for every corner of the globe.
If you loved this deep dive, let me know in the comments below. What ambitious megaproject should we tackle next? Japan's physics-defying maglev trains or futuristic desert megacities? Let me hear your thoughts. Don't forget to hit that like button and subscribe to Engineering the Impossible. Stay curious, keep building, and I'll see you in the next one.
Picture this, you're on a silent freezing glacier in Iceland. It feels like the coldest, most desolate place on Earth, but just a few miles directly beneath your boots an ocean. A liquid fire is churning, a restless magma chamber radiating violent pre-history. All the history, our instinct was to run from that fire. What if we didn't? We are talking about piercing the heart of an active volcano. Imagine a pitch black shaft dropping miles into the earth, leading directly to an ephemeris can liquefy solid steel in seconds. It's a multi-billion-dollar gamble with the laws of physics. Tiny miscalculation, it could trigger catastrophic. Welcome engineering the impossible. Today, we're deconstructing a mega project that sounds like science fiction. The Magma Tap. Let's face it, our power grids are gasping for air. Twin explosive, AI expansion in the birth of next megacities. We desperately need a limitless, desperately need a limitless. Perfect clean baseload power that never stops to find it. Our mission takes us to Iceland. Up top, Arctic wind scream. But deep underground, a fire monster is waiting. Engineers survive far to fit on the most strange destruction. Our 101 real. Writing of it as it's by Dane stump a cruise ship be built solely to grind on Megaprojects on Earth. So how do you reach the magma? You have to carve a flawless artery through miles of incredibly dense.